For the first question, explain the meaning of differentiation in mathematics. Differentiation in mathematics is a process of finding the derivative or rate of change of a function, in contrast to the abstract nature of the theory behind it. The practical technique of differentiation can be carried out by purely algebra manipulations using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate functions. Then, name 3 techniques of differentiation that you have learned in syllabus. The 3 techniques of differentiation that I have learned in the syllabus is chain rule, product rule, and implicit differentiation. For this question, we need to differentiate the function y equals to 5x cubic e to the power of cos x. Since this function has 2 terms multiplied together, we use the product rule. The product rule formula is dy dx equals to u dv dx plus v du dx. So first, let u equals to 5x cubic and v equals to e to the power of cos x. Now differentiate u, du over dx, it will be like du over dx equals to 15x squared. Next, we have to differentiate v equals to e to the power of cos x. So for this one, we have to use the chain rule because the exponent is cos x. The derivative of e to the power of cos x is dv dx equals to e to the power of cos x multiplied with negative sign x, which become negative e to the power of cos x sin x. Now, substitute everything into the product rule formula, which is dy dx times 5x cubic times negative e to the power cos x sin x plus e to the power cos x times 15x squared. Simplify and it will be negative 5x cubic e to the power cos x sin x plus 15x squared e to the power of cos x. Next, factor out the common terms 5x squared e to the power cos x. So it will be equals to 5x squared e to the power of cos x times 3 minus x sin x. So the final answer is dy dx 5x squared e to the power of cos x times 3 minus x sin x. So that's the differentiation using the product rule and chain rule together.
For question 2b, given the function is f of x is equal to ln 5x over sin 2x. First, we use the logarithm law. Ln a over b is equal to ln a minus with ln b. So, the function can be rewritten as f of x is equal to ln 5x minus with ln sin 2x. Next, differentiate each term separately. For ln 5x, we use formula d over dx. Ln u is equal to 1 over u times with du over dx. Therefore, d over dx ln 5x is equal to 1 over 5x times with 5. So, equal to 1 over x. Now, for ln sin 2x, we use the chain rule. D over dx ln sin 2x is equal to 1 over sin 2x times with d over dx sin 2x. Since d over dx sin 2x is equal to 2 cos 2x, we get 1 over sin 2x times with 2 cos 2x is equal to 2 cos 2x over sin 2x is equal to 2 cot 2x. Finally, combine both results. So, f prime of x is equal to 1 over x minus with 2 cot 2x. So, the final answer is f prime of x is equal to 1 over x minus with 2 cot 2x.
Given the equation y sin 2x minus ln 2y equal to 2x squared plus 3, we are required to find dy dx using implicit differentiation. First, I separate the equation into 3 parts, 1, 2, and 3. Now, differentiate each part with respect to x. For the first term, y sin 2x, I use the product rule because it involves 2 functions multiplied together. Let u equal to y, v equal to sin 2x. Then du dx equal to dy dx and dv dx equal to 2 cos 2x. Using the product rule formula, duv over dx equal to u dv dx plus v du dx. We get d dv dx y sin 2x equal to y 2 cos 2x and plus sin 2x dy dx, which simplify to 2y cos 2x and plus sin 2x dy dx. Next, differentiate the second term d dx ln 2y. Using the chain rule, the derivative of ln u is 1 over u du dx. So, d over dx ln 2y equal to 1 over 2y 2 dy dx equal to 1 over y dy dx. For the right hand side, d over dx 2x square plus 3 equal to 4x. Now, substitute everything back into the equation. 2y cos 2x plus sin 2x dy dx minus 1 over y dy dx equal to 4x. Next, collect all terms containing dy dx on one side. dy dx sin 2x minus 1 over y equal to 4x minus 2y cos 2x. Finally, divide both sides. dy dx equal to 4x minus 2y cos 2x over sin 2x minus 1 over y. To simplify the fraction, multiply the numerator and denominator by y. So, the final answer is dy over dx equal to 4xy minus 2y square cos 2x over y sin 2x over 1.
For question 4, we use the linear approximation method to estimate the value of the fourth root of 15.98 minus 2 over square root of 15.98. First, we assume 15.98 as x. Let f of x equal to fourth root of x minus 2 over square root of x. The fourth root of x can be written as x to the power of 1 over 4. So x power of 1 over 4 minus 2 over x power of 1 over 2. So we can get x power of 1 over 4 minus 2x power of negative 1 over 2. Next, we find the f prime of x. We can get f prime of x by differentiate the f of x. So f prime of x equal to 1 over 4x power of negative 3 over 4 minus with negative 1x power of negative 3 over 2. So we can get the 1 over 4x power of negative 3 over 4 plus x power of negative 3 over 2. Now we list the x, x0 and delta x. We can get the x from the given value, which is 15.98. The x0 we can choose a value that close to the 15.98 and easy to calculate, which is 16. And the delta x we can get by x minus with x0. So 15.98 minus with 16, we can get negative 0.02. Now we apply the formula of linear approximation method, which is f of x0 plus with delta x equal to f of x0 plus with f prime of x0 multiplied by delta x. The fourth root of 15.98 minus with 2 over square root of 15.98 equal to f of 16 plus with f prime of 16 multiplied by negative 0.02. We substitute the 16 into the x, which is 16 power of 1 over 4 minus with 2 times 16 power of negative 1 over 2 plus 1 over 4 times 16 power of 3 over 4 plus with 1 over 16 power of 3 over 2 multiply with negative 0.02. We get 3 over 2 plus 3 over 64 multiply with negative 0.02. We get the answer, which is 1.499.